Hello guys, my name is Divyaprakash and I'm a data scientist with over 1.5 years of experience. In this particular channel, I've taken up a challenge where I'm going to do data science for each and every day and I'm going to document the progress that I'm going to do. So as part of this, I was working on a project. It was based on an hull performance analysis where I had a data set of a ship's engine which contains various features like speed through water, speed over ground, wind speed, longitudes, latitudes, the fuel consumption, and other features like that. And the idea was to compute the performance of the ship over time and to forecast certain KPIs with relevance to the voyage the ship has been in. So this was the problem statement, and we kind of started in the last video. And we first investigated the data and kind of found kind of checked for any kind of missing data or discontinuity in the time series, and we try to visualize it. In this particular video, we'll dig more deep into it and investigate more into the data. Let's get started with it. This is the kind of setup we have right now. So this was the progress so far. So we were visualizing the gaps in the time series data, and the red ones represents the actual gaps between the discontinuity in the data set that we have. So that was the progress so far. So after that, what I mentioned in the previous video was we have the gaps, but we don't know the actual time difference between those gaps, because visually we can't say anything on it. Like we can say whether it is a small gap or a big gap, but we can't say how big or how small. So I wanted to investigate more on it, and since last time writing the code was a bit time taking process, it was tiring for you in the video itself. So what I thought was to actually pre-code it and then just execute things right here instead of not writing the code from the scratch. So what I did was I created a plot, scatter plot, to actually visualize the time gaps between these chunks. So to have a better clarity, I wanted to differentiate between the time frames which had very less gaps and the things that had very large gaps. So I created a flag column, which is this one, which would flag the gaps where the gap is larger than a day. So if the time gap is more than a day, I have a different color code for it, and if it is less than a day, I have a different color code for it. So that was the thing I did, and I plotted this scatter plot for all these buckets that I've created before. So when I execute this, so this was the plot I got. So as I mentioned, the green ones represents the time gaps where the gap between the buckets is actually very small, less than a day, maybe a couple of hours or 6 to 7 hours. And the time where the red ones are actually represents the gaps where the days are it is more than a day. So here you can see it is ranging from 2 days to up to 60 days, while there are a lot of clusters of data points where the gap is actually less than a day. So the green ones may actually represent a minor halt during the voyage, or some kind of works that's been done during the process of the voyage itself, while the red ones can actually represent any break in the actual voyage or a start of a new trip. So those kind of informations are very crucial to us while building a problem, because when we are building an auto-regressive model or a tree-based model to predict the KPIs that we are interested in, like the fuel consumption, it is very much needed for the model to differentiate between different voyages. It can't treat them as a single voyage. It gives a better clarity to the model if it knows if it is a start of the voyage or end of the voyage. So that is the reason why we are investigating more on this particular area before coming to any kind of conclusions. So since as we can see, there can be some kind of gaps between the voyages or a start of a new trips. What I wanted to do next was to segment the dataset into different voyages. So how we are going to do that actually? So one way of doing it is by calculating the distance between two consecutive points, and if we can see any kind of large distance, say for example if it is since the dataset is spaced 1 hour again, 1 hour after 1 hour. So practically it can't be more than 50 or 60 nautical miles. So that's kind of a domain knowledge that we can have here, and check whether the gap between those, the distance traveled by the ship between those 2 points is not abruptly more, like, if it is more than 100 or 200, definitely it is a break of a voyage. So, like, the data set, like, data set contains the end point of one voyage and the start point of the other voyage. So that's how we can interpret that. But still, the distance alone can't say. We need to check the time gap as well. The time gap also, we need to check whether it is uniformly spaced between 1 hour, or, like, is there any mismatch. We have already computed that, there was some kind of discontinuity between the time frame, so it is obvious right now, but we need to know, like, how long the time frame is. But yeah, so these the accumulative quantitative metric between the distance and the time will give us an actual shift in voyages. So we can't take the distance alone or time alone, because, like, for example, if the record is recorded between 9 hours gap and the distance is 1000 miles, which is actually valid. A ship can travel for 1000 nautical miles in 9 hours. So distance alone or time alone can't give us, but a quantitative metric which combines both, like a speed between them. So it is not actually speed, but a value like distance by time can quantify the abnormalities in the dataset. So that's what we are gonna do next, and segment the voyages, segment the dataset into different voyages. So for that, like, first we need to calculate the distance traveled by the ship between two consecutive points. If you take a look at the dataset, actually, data.head of 3, so we have okay, I'm not. So we have actually the longitude and latitude coordinates. So what we can do is kind of, sorry for the inconvenience. Yeah. So we have the longitude and latitude pairs for each and every point. What we can actually do is, like, compute the distance between 2 points. So that will actually give us the actual distance covered by the ship in terms of nautical miles. That's what we are gonna do. For that, like, I got this formula from ChatGPT to compute the distance between two longitude latitude pairs. So, like, it's called as the Haversine formula, which will take the latitude and longitude and the radius of the earth to compute the actual distance covered by them. So this was the function that I developed to compute this distance. So it's just the replica of the actual mathematical formula. So this function will return the distance traveled by the ship between two consecutive points. And then, like, I computed the distance here, and also I computed the time elapsed between two consecutive rows, and then using those two values I computed the implied speed between those two consecutive points. So these were the three features that I engineered for segmenting the dataset into different voyage trips. So I'll just execute those cells one by one. So this one, yeah. So, and then I wanted to have a look at the trend of the implied speed. To my idea is that, like, since if the voyage is breaking, there should be some spikes here and there between the speeds, between the implied speed trend. So if that is the case, we can conclude that, there is definitely a shift in voyage, because, like, the geographical location won't be that similar as compared to the previous years, because these entities that we are computing are in relevance with the previous record. So if you are having some kind of abnormality, which actually means that, the voyage had stopped at that particular point and a new voyage has been started from the point where we are observing a high abnormality in the implied speed. So that's my intuition. So, and then that's the reason why I plotted this plot, and I actually right now I can see some kind of spikes at random points. This might include the abnormalities in the implied speed itself. But, like, as I mentioned, like, this can't be more sorry, this alone can't give a conclusive evidence of um, the change in voyages. So what I did is, like, I kind of first had an inspection on all these things. I plotted a box plot to check, how the outliers are spaced, because these values are basically outliers, but visually the things that we are seeing is just three spikes. But if you plot a box plot and see, like, there are a number of outliers clustered here. So these are also abnormalities in the data set as compared to the entire population of samples. So we need to handle them in an efficient way. And before that, like, we can also have a distribution plot to see how this implied speed is distributed across the range. So this gives us that. So we can see that, the implied speed is, like, it's more situated in the 0 to very small distance, 50 or 60. It is populated more in that particular region, and all the else part are, like, it's very small amount of distribution only. So that's the key takeaway. So as we are more keen on identifying the outliers and abnormalities, so I checked, like, how many data points are less than zero point 0.5 speed. So this was basically done to not actually compute the abnormality. This was part of another inspection. So apart from the abnormal changes in the implied speed, a zero speed might also indicate something else. Say, for example, if our ship has been recording zero speed or very less amount of speed for a prolonged period of time, what that basically means, it means that, like, this ship is not traveled much distance and it's been waiting at particular point. This may be due to a climatic change, or it's been halting at a port to do some kind of loading and unloading stuff. So this is also an important metric that we need to see before we segregate the voyages in coherence with the abnormal change in the implied speed. So that was the reason why I wanted to check, because when we look at the plot, it seems like it is situated more near zero. So I wanted to have a count of data points where the implied speed is very less than 0.5. So I like, in a proportional way, I want to see that with respect to the entire length of the data set. And surprisingly, what I got was, like, around 60% of the data set where the implied speed was less than 0.5. It means that at most of the places the ship is being idle, and, like, it is like, maybe it can be a place where the ship is being loaded or unloaded at most of the times. But that gives a lot of information, because it is a huge number. 60% is a huge number, and we can able to see that, the ship is idle for most of the time. But the thing is, like, since we have 60% of the data, we can't just actually conclude that what are all the data points where the implied speed is less than 0.5 as an idle state. The ship can also have some kind of idleness during the voyage itself. Maybe it can be for an hour or two, but if it is prolonged, we can conclude that the voyage has been ended. So what I did was, coming to the voyage segmentation, so I considered two things. So one is, like, the speed between consecutive rows are extremely large. So that actually says that, the ship, the coordinates are actually changed from one point to another, so which indicates a change in the voyage. And the next one is a prolonged near to zero ratings in place of implied speed, which states that, the ship is in an idle state for a prolonged amount of period. So that was the next stage of investigation. And what I did was, first I plotted a plot to see at which part of the entire time frame my ship is actually being idle. So for that, first I computed the places where the ship recorded an implied speed less than 0.5, and then, like, I kind of had a binary column for it. And after getting that, I bucketed that binary column as we did for the missing data case. So a consecutive zeros and consecutive ones are clubbed into buckets. And what I did was, I kind of computed the length of these buckets. So the length of this buckets actually says for how long the state is in idle or is in active state. So if the idle state length is said to be more than 6 hours or 7 hours, it actually means that the ship has been not moved for 6 or 7 hours. We can conclude that those type of prolonged idle state as ships loading or unloading phase, while a minor change, 1 to 2 hours or 3 hours of idle can be neglected, because it can be it can be a process during the voyage as well. So that was the idea. So that's why I computed the segment length. And what I did was I had a threshold value of 6 hours. So any idle state which has a segment length of more than 6 hours, a prolonged 6 hours of idle gap, that was considered as prolonged idle flag. So this is again a binary column which will have zeros and ones for prolonged idle state. And then I bucketed the prolonged idle state of consecutive zeros and consecutive ones. This particular column actually contains the buckets which has, each bucket will have an active state, and the consecutive bucket will have an inactive state or idle state, and then again an active state, and then an inactive state, and it will go on until the end of the data set. So this is somehow similar to how we constructed the buckets for the missing values, where we had consecutive buckets for continuous data points and continuous missing values. So I kind of plotted a similar broken bar plot to visualize this as well. So I will show that, and we'll speak more on it after the visualization is being rendered. So let me just execute these cells. So yeah, so this is somehow very similar to the broken bar plot we plotted for the missing data points, but here it is kind of different. These gaps in between these green bars actually represents the idle states. You can say in these areas, for consecutively six or more hours, the ship's implied speed was less than 0.5, meaning that the distance covered divided by the time elapsed value for 6 or more consecutive rows or less than 0.5. So it actually contains a lot of information, and so this is how I kind of computed the idle states of the ship. So the next particular target is to actually find the points where the ship's speed is abnormally high, and kind of combine these two values to segregate the voyage of the ships into different voyage IDs. Say for example, if we have 5 different voyages, then each rows which is corresponding to that particular voyage will be having a separate ID. So that's going to be the future progress of this particular project. And once we get the voyage IDs, then we made some assumptions and came to one conclusion, and we segregated those voyages. So the next step will be to then validate the results that we have. So there are several ways to validate it. First we can visually inspect how the voyages are splitted, and then we can also do some kind of clustering to check clustering with the geographical coordinates. We have the longitude and latitude pairs. So clustering mechanism can understand the patterns between them and cluster them into different patterns, and this will work if the coordinates are completely different. It won't cater the part where the ship was idle. So I'm not very sure whether the clustering will be a good way to validate the responses, but visually we can actually validate it. So that is going to be the future progress of this particular project. But yeah, this is the kind of progress that we have right now. And yeah, currently we are getting to know more about the data. So once we have enough informations, then we can start building our model and doing our predictions. That's it for today. Thank you for watching, and I'll see you in the next video.